the standard enthalpy of formation of phenol is given to us.
Yes.
And we have to calculate the standard enthalpy of combustion. So first of all, we have to write down the equation. What is enthalpy of formation? I will write the whole definition. It is, first of all, whenever it is written enthalpy, it is for 1 mole. So now it is enthalpy of formation. That means 1 mole of something is formed.
Yes.
So 1 mole of compound is formed. So it is amount of enthalpy change when 1 mole of compound is formed from, this is very important thing, is formed from its constituent elements. Yes, in the not separate atoms, but in their elemental state, in their standard state, we can say, for standard enthalpy of formation. It is for standard enthalpy of formation. So amount of enthalpy change when 1 mole of that particular compound is formed from its constituent elements. So see, we have phenol C6H5OH. So what are the elements involved? And what is the standard state of carbon? Yes, yes. So yes, so keep in mind standard state of carbon, because they are in allotropic forms, diamond and graphite. So carbon and graphite, sulfur. What is standard state of sulfur? So it is rhombic sulfur. And phosphorus, it is white phosphorus.
So rhombic meaning
S8, S4, but rhombic, there is even S8 is monoclinic sulfur.
Yes.
Plastic sulfur, even P4 is white phosphorus, red phosphorus, black phosphorus. So these 3 standard states you have to remember, okay? And graphite is thermodynamically most stable form of carbon. It is thermodynamically most stable state of carbon. Rhombic sulfur is also thermodynamically most stable form of sulfur. But white phosphorus, it is not thermodynamically most stable, but it is abundant. That's why. Otherwise, white phosphorus is least stable. Most stable form of phosphorus is black phosphorus. But phosphorus, white phosphorus being abundant, is the standard form of phosphorus. Okay. So let us start with the equation. Phenol. So phenol is formed from carbon, that is graphite, and 6 carbon.
Yes.
And we will write hydrogen in the form of
H2 gas.
Yes, good. It is H2 gas and 6, so 3 H2 gas plus O2 gas.
Yes.
half of O2 gas. So keep in mind that C6H5OH should be 1 on the right side, and in that way you will balance the elements. Like see, there is half O2, but don't multiply by 2, otherwise it becomes twice the enthalpy of formation. So now enthalpy of formation, standard enthalpy of formation, it is given to us. It is not given to us. Yes, it is given minus 165 kilojoule per mole. It is minus 165 kilojoule per mole. So this is the equation for the standard enthalpy of formation of phenol. Now we have to calculate standard enthalpy of combustion of phenol. So what is enthalpy of combustion? Amount of energy released when 1 mole of compound is burned in excess of oxygen. So now it is, equation becomes C6H5OH liquid plus O2 gas, and it gives CO2 gas plus H2O liquid. So there are 6 carbons, so 6 CO2 and 3 H2. So 7, it is 15 by 2. Okay, 7, right, because 1 oxygen is in the phenol. Okay. So this is the equation. Now we have to calculate the value for it. So enthalpy of this reaction is, if standard enthalpy of formation are given, see, standard enthalpy of formation of CO2 is given, standard enthalpy of formation of H2O is given, and standard enthalpy of formation of any atom in its elemental state is 0. Very good. So for O2 it is 0.
Yes.
So now and whenever enthalpy of formation are given, that is sum of the standard enthalpy of formation of products minus sum of the standard enthalpies of formation of reactants. Okay. So now it is 6 into standard enthalpy of formation of CO2 plus 3 into standard enthalpy of formation of H2O minus 1 into standard enthalpy of formation of phenol. Okay, that means there is no need to write this equation, but anyhow, yes, it is good for you. Okay, so it is now 6 into value, what is the value? Minus 393.15 minus 393.15 plus 3 into minus 285.83 minus 1 into minus 165. So what is the value? 3053. So this is the standard enthalpy of combustion of phenol.